Welcome, Peter Ritt. Marcel Krok will introduce Peter Ritt, and I'll take just a few minutes of your time to have a brief context for the Netherlands for this talk. Maybe also for Peter Ritt himself, because he himself has, of course, his own context, being an Australian. He will tell everything about that. But this is a lecture which we called Icons, in a series which we called Icons of Alarmism. So that's, the topic is, of course, the idea is that it has become an eco-religion, and there are many symptoms of it. And the current talk is, apart from Corel, of course, is about one of the symptoms. So this was one of the oldest icons, you could say. It's just a picture, an image that people have, a hockey stick. People have that in their mind. They're alarmed due to the appearance of this hockey stick. And a modern version has appeared, but this was our own battle in the Netherlands. Our battle over the icon of the number of heat waves. So the red image is what occurred in the newspaper after our Met Office, our local Met Office, tampered with the data or reinterpreted historical data. Well, you've been able to read about that during the summer, of course. This is our counter icon, you could say. We reintroduced all eliminated heat waves in this graph. So this is our own battle for the Dutch climate icon, you could say. Of course, you know this one is also captures part of the discussion, and we will have Susan Crockford also together with Clintel. We organize a series of lectures by Susan in a few weeks' time. So keep an eye on the website for further information. For example, 17th, the weekend of 17th of November. So that's that battle, and of course, this is how it appears in the Dutch, news outlets. I think this is new.nl. It's of course the big advertisement. So free news must be unreliable news, but this is how people are being informed, of course, as late as 2019. Quite alarming, of course, but this is we need to introduce, of course, the facts and the counter-narrative to this. This is another example from Animals Today. Yeah, it's a Dutch information site, but there's also one example I found. And of course, our Ministry of Propaganda, or Ministry of Truth. Anyway, some ministry posted this video. You can look it up online. I won't play it, but it gave a range of temperatures, of increasing temperatures, and coming at +3 degrees warming, global warming, the corals would bleach and we would be out of coral. So that's our own government misinforming or alarming us. And so this is a symbol of our fact-based counter-narrative. We create an image of the nature as it truly is. From the top. That's the invention of Joep. He says, well, we'll profile ourselves with images from the top. So, especially with drones, that's possible. We create the overview on top of the facts, and we're on top of it. So that's a symbolism. Please, Marcel, introduce Peter Ritt.
Yeah, I will be very short. We were with a group of Dutch. We were in Oslo 2 weeks ago, and there we already met Peter, like Cyril just mentioned. We have a better and better European network of what we call climate realists or pragmatists or optimists or whatever name you give it, lukewarmers, you name it. And so we already had the pleasure to listen to him in Oslo, and I will be brief for the moment because most of you know what he is going to talk about. We had lunch this afternoon here in the hotel already, and one of the most striking things, and maybe he won't tell you, so I'm going to tell you, is that you all heard, of course, about his court case, that he was fired by the university. He fought against this and he won the case, but the university is going to appeal the decision. Yeah, so the battle will continue for the next couple of years probably. Because Peter now expects that they will go all the way to the what's called the Supreme Court? High Court. And one of the most striking things that he told me was that now the university, in the appeal, they hired one or maybe the most expensive lawyer in the country. $25,000 a day lawyer is now hired by the James Cook University to get rid of Mr. Ritt. So, please welcome him.
Do we have to put the other thing on? Yeah, well, they might have the Australia's highest paid lawyer, but we've got the truth on our side, so that should count for something, I hope. Anyway, so while we get the thing up, we're going to talk about the Great Barrier Reef, and of course you've heard everything, that it's completely in a terrible state. We had a big government report come out just a couple of weeks ago, which basically said that the Great Barrier Reef was in very poor condition. And you can just imagine what our tourist industry thought about our government telling the whole world that the Great Barrier Reef was in very poor condition. It would be like the French government saying that the Eiffel Tower was a rusty piece of scrap. They were totally. Yeah, that's right. So anyway, it doesn't matter where you look. We're told that the reef is in a dire situation. CNN, Japan Times, you name it. Even my cousin in England tells me when I go back there what bad state the reef is in. And it's not just climate change. In fact, I'm going to talk a little bit about agriculture before we go into the climate change thing, because in fact, sediment, mud from agriculture, nutrients, fertiliser, pesticides, dredging, climate change, overfishing, even some crazy things like medical drugs are supposedly killing the Great Barrier Reef, sunscreens, anti-foulant paste, even coal dust and land-derived fungal dust. All of these things are accused of killing the Great Barrier Reef. So, the climate change thing is just one thing, carbon dioxide, but here it's half a dozen or more things that are killing the reef. Now, why does this matter? Well, it's not just the climate change thing, and I will talk about the agriculture. The fact at the moment is that every industry in North Queensland, northern Eastern Australia, is affected by legislation that's affected by the Great Barrier Reef. And not just that, it's mining, tourism, the whole lot, the cattle industry, the sugarcane industry. So this is actually, not quite life and death, but it is a question of whether some of these industries are literally going to survive. Now, there are plenty of unhappy farmers around. These are some Dutch farmers who are worried about nitrogen. I think it's ammonia in your case. Well, here's some Australian farmers that are equally worried but not quite so well organised, and they're worried about the nitrogen coming off their farms, supposedly killing the reef. And I'm going to talk about that to start with before we move on to the climate change, because at the bottom of the problem we've got here is the fact that our science institutions are untrustworthy. In the end, that's the problem, right? And they're not just untrustworthy on climate change stuff, they're also untrustworthy on the impact of the agriculture on the reef. Now, the important thing about the reef is, here's northeastern Australia, and this is the Great Barrier Reef, and it's actually mostly quite a long way from the coast. That's about 100 kilometres, all right, down to about 50 kilometres. Gets a bit closer in the north. And this is very important from the point of view of agriculture, because, it's a long way. So the reef is made up of about 3,000 individual reefs. So these are reefs that were somewhere down here, individual ones. If you blow them up, this is what they look like. There's about 3,000 of those ones. And here's a picture of one, just one individual one. We've got the beautiful water, the reef usually fringing around the side, a little bit on the top, but this is mostly calcium carbonate, rubble and sand. and a bit of reef on the top here and a fair bit of reef on the back. That's what they look like. Now the important thing about that picture is look how white and beautiful the sand is, right? And remember that and we're going to mention this, that the farmers are accused of killing the reef, but with all the mud that comes off their farms. All right, so this is another view of the reef. This is Cairns, the famous tourist destination, and the land. And the Great Barrier Reef, this distance here is, about 60 kilometres, and these are the individual reefs. And then you go into the deep water in the Pacific Ocean, 1,000 metres deep. Here it's 100 metres deep. And we're going to mention these inshore reefs, all right? Now, the inshore reefs, I've got an arrow going to them, but you can't see them because they're very, very small, right? And, of course, it's these inshore reefs. They're just tiny little fringing reefs. They're not even the Great Barrier Reef itself. And these are the ones that, generally speaking, are supposedly affected by the farming. All right, another picture. Each of these individual reefs is a plateau that sticks up in water that might be 50 metres deep here, and it comes up to the surface. And these have grown over a few million years in the latest incarnation. So the reef at the moment is only 18,000 years old. When the sea level rose, these were, before that, these were just flat-topped hills. They were covered again with water, and the reef started to grow on them again, and they rise up a little bit further. These ones here will rise up, and eventually, over a few million years, we ended up with the Great Barrier Reef. But it comes and it goes. It lives and it dies. And most of the time, over the last 100,000 years, the reef has not actually existed. All right, now we're going to look at this, to start off with, the sediment and the nutrients and pesticides from agriculture. All right, so let's firstly look at mud from farms. So soil erosion. Australia is not quite as flat as Holland, so there's quite a lot of erosion from some farms. And supposedly the mud is killing the Great Barrier Reef. Now this is a typical picture of a not quite so typical reef. It's a very famous reef. And you'll notice how white the sand is. That sand is white because it's calcium carbonate. It's made up of broken coral that's been ground up. And there is no mud on this reef. If you take a sample of that sand, it's not zero mud, but it's close to zero mud. So the question is, how can the farmers be killing this reef if there is no mud on it? Now, this is one of the, what we call, this is the Great Barrier Reef itself, which is where 99% of the coral in this area is. And yet there is no mud on it, but the farmers are accused of killing it. It's a crazy situation. It's like saying climate change is being caused by carbon dioxide in the circumstances where carbon dioxide wasn't even rising, right? There is no mud on these. How can it possibly be affecting this? It's an even more ridiculous situation than the carbon dioxide climate link. Another famous island, one of the famous closest reefs to the mainland here, there's the mainland, and you can see again sparkling clear white coral sand, no mud there at all. And as I said, the reason is the reef is a long way from the coast. It's difficult for any of this mud to get out there. However, just occasionally, very, very occasionally, we have a big flood. Now, you've got to remember that Australia is not like Europe. Most rivers in Australia are dry for most of the time, right? They don't have any water in them whatsoever for most of the time. But then you get a really big amount of rainfall where we can get a metre of rain in just a few days and they flood, right? This is one of the biggest rivers. And what you see here is the coast, and this is one of the closest reefs. All the reefs are actually out here and away. And this muddy water just managed to get to one of the reefs. And these pictures are often used to demonstrate how terrible the farmers are killing the Great Barrier Reef. But in fact, they show effectively the exact opposite. Sorry about that. What they actually show is that, remember, this river, this plume may not happen again for another 10 years. And the plume only just got to 2 or 3 of the 3,000 reefs, and when you actually measured the amount of sediment that was in here, it was very small. So what this actually proves is the opposite, that in fact that a tiny amount of sediment reaches 1 or 2 of the reefs very infrequently. It actually proves the opposite. If you took a photograph of this area today, tomorrow, it will show sparkling clear water, the mud doesn't get out there at all. However, the inshore reefs, so this is the land, and here is a reef. It looks totally different, looks terrible. It's surrounded by all this muddy water, but there's a very vibrant, living coral reef there. Very high amount of mud because this area is surrounded by mud that's been laid down for thousands of years. It's been there for thousands of years. Every time the wind blows, you can see the waves here. It churns up the seabed and it makes it muddy. And this is a totally different type of reef with different species of coral that lives quite happily under these muddy conditions. And the extra amount of sediment that comes down from farms since European settlement is insignificant compared with the amount of mud that's already suspended. So even these inshore reefs are not affected by the farmers. The bottom picture shows what happens when it's a windy day. All right, so this is the coastline, and you can see the reef is out here, and you can see all this muddy water. Maybe it's not that easy to see, but there's all this muddy water for 10 or 15 kilometres offshore every time you get a strong wind, and that is far more important than the river plumes in terms of killing the reef. No, I shouldn't say killing the reef, affecting the reef by sediment. And then we have cyclones, all right? And cyclones are the really important thing. A cyclone can completely destroy a very large fraction of the reef. A big cyclone like this one, Tropical Cyclone Yasi, can move 500 million cubic metres of sediment, right? A distance maybe 50 to 100 kilometres wide. It would churn up the seabed by 10 to 20 centimetres over maybe a distance of another 100 kilometres. It moves an enormous amount of sediment compared to the rivers. These are the most important things on the Great Barrier Reef in terms of coral death. All right, but there's other forms of pollution. There's nutrient pollution. Here's another completely typical picture. This really is a typical picture of the Great Barrier Reef, is what it looks like almost every day. And you see beautiful clear water. And the reason it's beautifully clear is that the Pacific Ocean is just offshore there, and large amounts of water from the Pacific Ocean come in and they come around the reef. The land and the rivers are irrelevant compared to the amount of water that comes in from the Pacific Ocean. And in fact, there's as much water comes in from the Pacific Ocean and then out in just 8 hours as comes down all the rivers along the whole Queensland coast in a whole year. Rivers, great monstrous rivers of oceanic water, the ocean currents, are much more important. So the reef is not particularly polluted at all. All right, so this brings us on to the situation of coral bleaching, which you've doubtless heard about. And it really is a story made in heaven if you want to prove that climate change is real, because the fact of the matter is that corals bleach when it gets hot. There's no doubt about that. By the way, they also bleach when it gets cold, and they bleach when there's too much fresh water. In fact, fresh water is the worst thing for them. They bleach under almost all circumstances when they're stressed. So it's spectacular and it's plausible. So let's talk a little bit about it. Right. The first thing we're going to say is that when it comes to temperature, there is no doubt that corals are obviously a tropical species and they like it hot. You do not go to Holland or England or Scotland to find good corals. Those that corals do live in Scotland, okay? They don't grow very fast, but you don't go there to see the corals. So here's a picture of temperature, 23 degrees up to 29 degrees, and this is essentially the coral growth rate. And unsurprisingly, as the temperature increases, the coral growth rate increases. And this is obvious, right? The best corals in the world are actually north of Australia, around Papua New Guinea, Indonesia and Thailand, in an area known as the Coral Triangle. It's also known as a hot spot in oceanography circles. And that's where the species diversity is the highest. And also, it's where the growth rate is actually at the highest. And the southern Great Barrier Reef grows a lot slower than the northern Great Barrier Reef, maybe only half as fast in some instances. So warm water is good. A moderate increase in the temperature, whether it's caused by burning coal or it's natural, is unequivocally a good thing for the Great Barrier Reef. There's no ifs, no buts about that. All right, but what's this bleaching thing? Right. So the first thing you've got to remember about coral is that a great big chunk of coral is made up of millions or thousands of little polyps, which is an animal, and inside the little animal grow little microscopic algae, zooxanthellae, and they are a symbiotic relationship. And essentially what happens is that bleaching is when the coral expels these algae, and the algae give the coral its energy, so they're pretty important. It's important that if the coral expels those zooxanthellae, it gets them back reasonably quickly, otherwise it will starve to death. All right? Right, and the other thing you've got to remember is that coral's made of these, sometimes you have them in these ornate patterns, staghorn-like corals, or these massive corals, and that's important. We'll see that in a second. All right, now, the important thing about this is that it's actually a masterpiece of cooperation. When the coral is born, in fact, it has no zooxanthellae. It takes them in. They're floating around in the water. Come back to that in a second. The bleaching is not a death sentence, right? So most of the time, after bleaching, the coral will get the zooxanthellae back and it will live. And in Australia, we have a similar sort of situation with trees where if it gets really dry, the trees drop all their leaves. It looks terrible. And they do that as a defensive mechanism to stop loss of water. Bleaching should be considered in the same way. It's not a death sentence. It's a defence strategy. It's a strategy for life. All right, and we'll probably just move on to the next one. I think I've dealt with all of that. Right. Now, the important thing, another important thing about bleaching is that the type of coral that is most susceptible to bleaching are these, these are staghorn coral or Cropera, and these have a very, very short life expectancy, right? See how delicate they are, they can be broken off, and what happens is that a hurricane will usually kill these within about 20 years, right? There's no point in these things having a long-term strategy to live for 100 years, because they're not going to. They're going to get wiped out. And these ones actually are very susceptible to bleaching. We'll see why in a second, actually. I call them the weeds of the Great Barrier Reef. They have a philosophy of live fast, die young. Whereas these things here, that coral there is probably 150 years old, all right? And they are far less susceptible to bleaching. They are also not killed by a hurricane, whereas these ones are killed by a hurricane. Why is that important? Well, it turns out that corals are incredibly clever, right? They've been around for a couple 100 million years, and they basically play a game of roulette with the zooxanthellae. It turns out that there are lots of different species of zooxanthellae, and depending on which type of zooxanthellae that the coral brings in, it can either grow really fast but be susceptible to bleaching, right? I would call, or it can grow very slowly, but be unsusceptible to bleaching. You can see there's a trade-off there. The coral decides, am I going to grow really fast but be bleached, or am I going to go really slow and not be bleached? And so it will decide which one of those ones it wants to do. And there's no hard temperature threshold, all right? So depending on what zooxanthellae is inside the coral, it might bleach 27 degrees, 28 degrees, or 29 degrees. Same coral, different zooxanthellae, you get a different situation. All right, so they can choose. So when the coral expels the zooxanthellae, it will usually still live, and it will take in possibly a different zooxanthellae, which makes it less susceptible to bleaching in the future. But the thing about these staghorn type corals is that there's no point in growing slowly. There's no point in growing slowly because you're going to get wiped out in 20 years by a cyclone. The idea is to grow as fast as you can, and if you get bleached, well, that's just unlucky, right? So this is the strategy that they have. We've also got to remember, if we look at the temperature in the Great Barrier Reef waters from, say, 1600 up to present, yep, we're reasonably hot, but when Captain Cook found the east coast of Australia, it was probably about the same temperature as it is now. So it's not necessarily even hotter. I regard bleaching as a little bit like a bushfire in the Australian bush, right? It looks terrible. You have a nice forest, it looks terrible, and it grows back, right? And but this is just the way that they are. And the thing about the reefs are that they tend to die in massive amounts, not by small amounts, they die in massive amounts. The other thing about corals is that not only do they have this ability to what we call shuffle the zooxanthellae, so all they need to do to adapt to a temperature increase of a degree or 2 degrees, or a temperature decrease of 1 or 2 degrees, is change the zooxanthellae. Right? That's all they have to do, and they're floating around in the water. This is a brilliant system. Think about all other animals. They have to go through multiple generations, and the genetics has to change, and evolution has to go on, maybe for hundreds of thousands of years. For a coral, just change the zooxanthellae. You can do it in a couple of months. So they have a masterful strategy. And of course, it's not surprising that they have a strategy like that, because the way that coral reproduces is it releases its eggs and it floats around in the ocean. And if a coral spawns, say here, it could drift north in the North Queensland current and settle way to the north where the climate is a lot hotter, or it could drift south in the East Australia current and end up here where it's way cooler, or it can go inshore where it's way hotter and colder, depending on the season, or it can go deep where it's colder. So the temperature changes that it's got to deal with of 1 or 2 degrees, it has to deal with those all the time, even if there was no climate change. So it's not surprising they can deal with a little bit of a temperature change over the period. All right, I want to talk a little bit about the ocean acidification problem, and I actually regard this as a potential worry for the Great Barrier Reef, but I'm not terribly worried about it. So as the carbon dioxide concentration increases, the pH of the ocean changes. It will never become acidic or anything like it. Presently, pH of about 8.1. It might get down to, say, 7.7 if we have a very, very high levels of carbon dioxide. And there is certainly some evidence to suggest that some of these calcifying organisms, like coral, have a slowdown in the calcification. And that's one of the reasons why I'm a little bit concerned about it. In my mind, it's the only viable threat to the Great Barrier Reef. The temperature rise is not a problem. But as I say, don't panic yet. I'll show you why in a little bit. Right, well, maybe I should have eaten my word. Here's a picture of the coral growth rates from date 1990 to the year 2000. You see them go along and they collapsed, all right? And this was attributed to the carbon dioxide level going up, reducing the calcification rate. The only problem was the two major flaws in this paper, and we detected those flaws. I'll explain them. So the way you work out calcification rate is you take a large lump of coral like that, you drill a hole in it, it is here, and the coral actually grows like tree rings, one ring every year. You can see each of these rings, and you measure the density and the width of those, and you can work out the calcification rate, and this is what you get. And they claimed that there was a collapse. The problem was that there were two errors, as I mentioned before. I won't go into what those errors are because that will take too long. But when we corrected it, in fact, we see that, if anything, the growth rates keep on going up. By the way, the dotted lines are the error margins. So if you actually take the error margins into account, well, you'd be a little bit brave to say that that's an increase, but it certainly isn't a decrease. And this, in our view, is certainly wrong. And interestingly, the organisation that's responsible for this is still not accepting that they're wrong. And even worse, this data ends in 2003, right? The suspect data actually starts in 1990. We actually don't have any decent data of coral growth rates, at least in this batch, from 1990 to the present. That's almost 30 years where we don't actually have decent coral growth rates, even though we're saying to this organisation, you should be going out there right now and measuring this again, and you will find that this will not exist. But they're not interested in doing that, which is a disgrace. All right, but there's one other group that have actually looked at the growth rates of coral, and they do go past 1990, and they found for the offshore, what we call the offshore and mid-shelf reef, there's about a 10% increase in the coral growth rates, which is great. And by the way, the offshore and mid-shelf reefs are 99% of the coral. However, they found a decrease of about 5% for these very small 1% of the reef that lives inshore. So for 99% of the coral, about a 10% increase in growth rate since the 1940s, which, by the way, is exactly what you would predict, because with temperature rise, you will get faster growth rate. It actually is a beautiful fit. But incredibly, these guys, despite finding that the coral growth rate is going up, they said, our findings nevertheless continue to raise concerns. The more pristine mid and outer shelf reefs appear to be undergoing a transition from increasing to decreasing rates of calcification. What? 11% increase, guys. How did you work that out? Right? It's just incredible that you take an unequivocal good news story and you make it into a bad news story. All right, so this is, when I'm talking about the acidification, the reason why I'm not too worried about it is because, in fact, so much of this science is just utterly untrustworthy. The scientific organisations are untrustworthy. So let's actually see. I want to talk about quality assurance processes, especially in environmental science. And of course, everybody knows about peer review. Peer review, if you ask somebody in the public, and I guess you guys are from the public, if you ask them what peer review is, most of them have this mental picture of there's a piece of work by a scientist and it's going to be peer reviewed and it gets given to maybe 12 other scientists and they pore over it for a month and they redo the experiment and they redo the all the analyses, and after that they meet together and they say yes it's right or no it's wrong. But in fact what it really is this piece of work is given to 2 other scientists and they may only look at it for 2 hours, they might look at it for a day, and they may be the friends of the original scientist. And that is peer review. It's a joke. It is just an absolute scandal. And it's not just a scandal that it's so pathetic. What is the real scandal is that scientists try to make out that it's more than what it is, right? Fortunately, there are some scientists who actually tell it for what it actually is. So this is Richard Horton, who's the editor-in-chief of the Lancet Journal, which is one of medicine's most prestigious journals, and he said, "We know that the system of peer review is biased, unjust, unaccountable, incomplete, easily fixed, often insulting, usually ignorant, occasionally foolish, and frequently wrong." Now that is the system of quality assurance we use for Great Barrier Reef science and climate science and just about any other science. It's a scandal. So I want to talk about the replication crisis. So we don't just have a problem with climate science or Great Barrier Reef science. We've actually got a huge problem in science, full stop. So the replication crisis is where we find that when we try to replicate other work, right, so when studies are going to do where we say, well, there's these 20 papers, we're going to see if we can replicate those 20 papers. Basically, when they do that, they find that half of them are found to be wrong. So we have a situation where about half of the scientific literature is wrong. So you've got to ask the question, who would you trust most, a used car salesman or a scientist? And the answer is not a scientist. Right? Because when you buy a used car, at least half the time that car will work, whereas half the science actually is wrong. Do you know of any other profession that is even close to as untrustworthy as that? And I'm a scientist, so it's very, very sad. This thing's not going to go on. Please move on. You can move on. It obviously doesn't like what I'm saying here. Oh, there we go. All right. So the father of the replication crisis, this guy here, John Ionides, and he published this remarkable paper with one of the most cited papers in the history of science, with the most incredible title, "Why Most Published Research Findings Are False." Right? That's an incredible title, isn't it? And him and a few others reckon that about 85% of scientific resources are wasted because we're basing it on science which was wrong in the first place, and it might take 10 years before that's found out. And the good news is that some of the funding bodies are accepting that this is a problem, even though at the moment it's very difficult to fund a replication study. I've tried to the Australian Research Council to do a replication study on Great Barrier Reef research, and the response came back, this is against the funding rules because it does not find new knowledge. We do not fund replication. even though replication is at the heart of the scientific method. And, you know, there's been a lot of this stuff, especially in the biomedical literature. So a very famous article in The Economist magazine which looked at when drug companies want to develop a new drug, they'll often take a promising piece of research from a university. You know, some professor finds this chemical coming from an exotic plant, it cures cancer. So the drug company, what's the first thing that the drug company will do? They will do the experiment again. Right? And what they find out that when they do this experiment again is that they're wrong about 80% of the time. Right? 80% of the time for some of these things. And the rule of thumb is that at least half of it is wrong. So, not good. So if we come back to Horton again, he says, the case against science is straightforward. Much of the scientific literature, perhaps half, may simply be untrue, afflicted by studies with small sample size, tiny effects, invalid exploratory analysis and flagrant conflicts of interest. Together with an obsession for pursuing fashionable trends of dubious importance, science has taken a turn towards darkness. And you really can't argue with much of that. But there are people who are seeing that we have a problem. And these two are environmental scientists. They're actually marine scientists. And this one in particular is calling for organised scepticism in the marine science. So he's saying the scientific community concerned with problems of the marine ecosystem should undertake rigorous and systematic audits. And that's essentially what I'm saying. So there is good news. And one of these guys, this Brownman guy, recently, he's an editor of a major journal. He actually had a special issue where he's looking at ocean acidification. And he says we've got to apply organised scepticism to the ocean acidification research. And he made the point that, in fact, there's lots of studies that show that acidification is not a problem. But they're also much more difficult to get them published. And he actually called for papers that showed no effect. So if you were a scientist and you did an experiment, you found no effect from acidification, then he wanted to publish those papers. So that was good news. So that's why I think we don't necessarily need to worry too much about it. So we know we've got problems in pharmaceuticals, psychology and all these things. And you know, the question that I keep on asking is, do we have decent systems of replication and checking in the environmental sciences? The answer is no. But unlike pharmacy and medicine, is there a chance that many marine scientists are partially driven by ideology? Well, I can tell you, when you talk to most of the marine biologists, they are. Okay, I'm a physicist. One of the reasons why I have a different view on this is because I don't have that marine biology background. And is there a chance that peer review amongst this group is self-selecting of the dominant idea? Peer review is a system that automatically and will always almost result in groupthink. That's what peer review does. If you're outside the peer review, you're excluded, no funding, can't publish, it's the end. And is there a robust debate without intimidation? So I asked the question, what would happen if a scientist questioned the trustworthiness of science organisation, which is what I did. Right. All right, but look, there are so many other examples of untrustworthiness in Great Barrier Reef science. So you may have heard that 93% of the reef bleached, implying, by the way, that 93% died from the 2016 bleaching event. Well, in actual fact, when you tot up the numbers properly, about 8% of the reef died in the 2016 bleaching event. And that sounds like a lot, doesn't it? But it's not, because it regrows so rapidly. So between about 2011 and 2015, there was a 250% increase in the amount of coral on the southern third or 40% of the reef just in just a few years. So an 8% reduction is nothing. You may have heard of these crown of thorns starfish plagues, which are eating the coral. This was the first big scare in the late 1960s. Right? So this has been going on for a long time for us North Queenslanders. We're partly sick of it, all right? But these starfish plagues are almost certainly natural. The geologists are telling us that they've been occurring for, since time immemorial. One of my most favourite papers, though, is one that says coal dust is killing the reef, right? So coal dust, we're a big coal exporter in Queensland. We've got some big coal mines, right? And of course, the environmental groups love to pick on them. And there's this famous paper said that this coal dust was spreading up to 200 kilometres away. The only problem was that they made a big mistake with their arithmetic and they exaggerated the concentration by about 3,000%, and then somebody else exaggerated the area by another factor of 10, another 1,000%. Complete rubbish. In fact, it's highly questionable that they were actually even measuring coal at all, full stop. Right. And then there's the situation, pesticides are supposedly killing the reef. But actually, on the reef itself, where 99% of the corals are, they almost never even bother to measure them. They're in such low concentrations they are undetectable even with the most sensitive scientific equipment. And even on the inshore reefs, which are only 1% of the coral, the levels are incredibly low. And then there's this one here where pharmaceuticals from sewage is supposedly killing the reef. Well, it's a medium risk. And I looked at this. This is where, you take a headache tablet, it passes through your body, down the toilet, into the sewage treatment plant, then it goes 100 kilometres off to the reef and kills the reef. And you think, how can this be? So, because I've got because I've had a fair bit of time recently on my hands, I've been able to really drill down into these things, and you find the paper and you go to the report, you go to the appendix, and you look for, well, what were the concentrations of pharmaceuticals on the reef? And you find they didn't even measure it on the reef. They didn't even measure it close inshore. Almost all the measurements were on the output pipe of the sewage treatment plant, and even there they were very low, and somehow they managed to say that as a medium risk to the reef, even though there is no taking into account of the billions of times dilution that will undoubtedly occur. All right, I'm going to move on past these ones and just talk about the amount of coral cover. So this is for the northern part of the Great Barrier Reef. By the way, these numbers are reliable from about 1990 onwards. They're not reliable before then. Anyway, they go along and you see this crash. Right? That was the 2016 bleaching event in the northern zone. It's coming good already. In another few years, it will be up here, but you won't hear about that in your newspapers. For the central zone, you see it going up and down. Big cyclone here, big rebound, big crash with another bleaching event. This was a nasty cyclone that went down the coast and wiped out a huge amount of coral on the reef. I'll show you how much. Right, here it is here. Comes along, up and down, crash. And then massive recovery and a little bit more loss from another cyclone. Overall, the amount of coral on the reef, this big crash due to the cyclone in 2011, overall, there's about the same amount of coral now as when records actually began. There is nothing in the data to be particularly concerned about. Will I talk about this one? No, I'm not going to talk about that one. It's another example of just some shocking science No, I'm going to talk about one because it's just so bad. They sometimes mention, and there was a journalist who was in today, and he actually knew about this data. He didn't know about the actual graph, but he'd heard that if you go back to the 1960s, the coral cover was way higher than it is today. And when you look at this data, you'll notice that it goes along, it's scattered, and then suddenly it sort of gets tight. In fact, if you extend this to 2020, it's very tight. It comes back up to about here, right? And so the early data is all scattered, and then the rest of the data is not. And the reason is that this data here is good data from what we call the AIMS long-term monitoring, where they take 100 reefs and they go around every one of these reefs and they do transects of coral cover, the amount of coral on the reef. And whereas the data beforehand, they didn't do these regular surveys. So say for 1970, that data point will be, they'll go to the scientific literature and they'll find some guy, blogs et al. Found in just a little patch of reef that the coral cover was such and such. And then on this day it was Jones who did something. And so totally different methodology used on each of these points and totally different to what happened. So you can't do that. You can't, in science, you've got to keep your methodology the same. That's one of the fundamental things. But it gets worse than that because the author of this graph hasn't even provided the raw data from where he got it from. We have asked again and again, we've asked the Nature Journal to supply the data. and he refuses to do it, and he also refuses to give us the methodology about how he got these points. So essentially, this whole data is complete rubbish. We tried to replicate it. So we tried to go back to the literature and get the same numbers. These are our numbers, these are their numbers. They should line up on this slide here, and they're totally scattered. So this is an example of a paper that should be completely scrapped, and yet it's a very important paper, being cited thousands of times. All right, so let's do a summary of the Great Barrier Reef. Essentially, the coral cover has not changed. There's still excellent coral on all 3,000 of the reefs. Sometimes it gets wiped out by a cyclone. A cyclone or a hurricane, we call them cyclones, can wipe out as much coral as the whole of Holland and Belgium put together, right? And it can do that overnight, but it regrows. But of course, it makes great spectacle, it makes great headlines when you've lost half the Great Barrier Reef overnight. The coral growth rates have not declined. If there is an effect from ocean acidification, we're certainly not seeing it yet. And they may well have increased. Crown of thorn starfish plagues are almost certainly totally natural. Maybe there will be a problem with pH, but there's none now. The land-derived sediment is utterly not affecting the reef where 99% of the corals live, even though that is having a major effect on our farmers. Nutrients are also having a minor effect on the reef, as are pesticides. But our main problem is we have huge problems with the reliability of our science institutions. They're just untrustworthy. It's as simple as that. And we need to institute methods to bring back reliability. We've got to replace peer review with serious peer review, where it's done properly, the way people think it is done, the way that the layman thinks it actually occurs. That is what we have to do. And we've in Australia at the moment, there's quite a large group of us now that are pushing for this at a very high government level, and I think we're going to succeed. I think in the next few years we will see proper reviews of this. And look, the take-home message is that the reef is absolutely fabulous, right? It's absolutely fabulous. You should come and see it. You really got to come and see it. Thanks very much.
Peter, could you maybe, you said close to nothing about your legal fight, except for the GoFundMe page.
Oh yes, that's right.
Could you maybe summarize in 5 or 10 more minutes why you got fired in the first place and how it...
Yeah, so it sort of built up over a period of a few years. So I was constantly questioning the reliability of a lot of the scientific evidence. I then, I will talk about these pictures here because they were partly the reason why I got fired. This is a picture of a reef on the coast in 1883. You can see there's quite good coral. This is good coral. Supposedly this is the same reef now, and there's no coral there whatsoever. And this is a very famous picture used all the time. It's a bit like the hockey stick curve, iconic picture. And I'd always been suspicious about this, and I employed a lot of people, and when they were driving past this, I said, go and check this out and see if there's any coral. And there's fantastic coral all over. And I spoke to a journalist about that, and I got a censure. The university didn't like me talking to the journalist about it. And then later on, I published a paper about the effect of climate change on the reef. And I spoke to a journalist, and I said, if scientific institutions use only peer review as their quality assurance system, where we know that about 50% must be regarded as wrong, then by definition their work must be regarded as untrustworthy. And they didn't like that. And then things went from bad to worse. They read all my emails. They told me I wasn't allowed to talk to my wife about the allegations they made against me. We went legal, and it got very ugly. We went to court. We had a GoFundMe campaign to raise 260,000 Australian dollars for our legal fight. We had to throw in another $200,000 out of our own personal, my wife and I, and we won the case. But now they're appealing. We think it will go to the High Court. We've now raised on this GoFundMe page, we've raised another about $650,000 because they've got Australia's most expensive law, and we've got Australia's about second most expensive law. The amounts of money are just ridiculous, and we're probably getting close to what we need to go to the next level of the judicial system. But we know that the university is utterly determined to crush us, and even if we win at the next level, we know that we'll almost certainly have to go to the High Court. So altogether, we're going to need probably about $1.5 million, and we're not far short of being halfway there, and we will get there.
And what about? I understood that the judge only was saying something about the agreement you had with the university.
Yes, yeah.
Not on the science, not...
No. So the judge...
Peter, could you repeat the question?
Yeah. So the question was that the judge wasn't adjudicating on whether climate change was real or whether the Great Barrier Reef is really damaged. He was adjudicating on whether or not the university had a right to essentially take away my intellectual freedom. So at a university, you should be able to speak what you think. If you've got an opinion on something, you should be able to say it, and your employer shouldn't be able to fire you for that. And essentially, the judge decided in our favour entirely on every account that the university had infringed my rights in that work contract. But he did make a specific point that he wasn't going to adjudicate on whether or not climate change is real or anything like that, which is fair enough, yeah.
Even een puntje van orde. Als je een vraag hebt, ga even staan en probeer zo luid en duidelijk mogelijk, dan kan de camera het misschien oppikken. En dat is handig voor later. Ja?
So, in the computer science industry, you have the FAIR principles, where we're trying to get our data out there and publish the data as well as the paper and our methods.
Yes.
So, what is preventing the marine biology fields from applying these same principles to their studies?
Well, there's nothing. And to be fair, some of the organisations are very good. The Australian Institute of Marine Science, whenever I've asked them, they've always handed over the data. It's sometimes taken a month or two, but that's fine. You know, they just need to get it together. But in other instances, individual scientists have dug in. So generally speaking, you can get it, but not always.
So would you be a proponent for judicially mandating scientists to publish their data as well as their methods?
Well, not necessarily mandating at a government level, but I just think that if a government is going to because the government actually uses some of that stuff, if a government is going to use it and the scientists won't hand over the data, then as far as I'm concerned, it's just ruled out. We're just not going to look at it. If you won't hand over the data, then forget it. But we need to go further. If work has only been peer-reviewed, then it's not good enough, right? It needs to be properly peer-reviewed before a government should use work that is going to be used for public policy that's going to affect the livelihoods of a lot of people. And so that's the other thing which we need to do.
All right, thanks very much.
Thank you.
Good evening. I'm what you would describe a layman, so I'm not a scientist. So I grew up with the alarmist stories, and this is the first time I get involved and I hear your story now. So I've not decided yet who to believe, which I think is a bad thing, because in science you shouldn't believe, you should look at the facts. That's what I know. What I miss in your presentation is, what is then the driver of the alarmists of the coral? Why do people keep telling me that the coral is going to die? It's bad for tourism. It's bad for Australia, I would say. Why would that? Why? What can you say about that?
Well, there's a problem with peer review that it excludes contrarians. But then you've got to ask, well, why is the group that have control of the agenda? Why do they believe it? Generally speaking, in my view, most marine biologists they literally love the reef. They literally love it. I've seen, when large amounts of coral has died, I've seen some marine biologists talking on the media, and they're talking in a way that a mother would talk about, a sick child or something like, literally, right? So there's a degree of emotion there that you may not get in other areas. And yes, there are, some people say, they just do it to get grant funding, but I actually don't believe that. Most scientists who go along with this, they really believe it. Yes, it's convenient that it's also good for their grant applications as well. But I think the bigger problem is the emotion. And, it's not a coincidence that myself and some of the other contrarians on this are not marine biologists. So I'm a physicist. One of the main guys that I work with is a geologist, and that is not a coincidence.
But wouldn't the tourism sector be more adamant about telling that this is not the case? Please continue visiting the reef because it's still beautiful.
They certainly do, and even more so now, because there's definitely been a reduction in the numbers. And what they hear, I talk to quite a few of these tourist operators, and what they hear again and again and again is, when some tourist has been out there and had a really great time, they said, well, we thought the whole thing was dead. And they said, and in fact, there's two types of tourism. There's those that think it's dead and you know, not really expecting very much. And there's those that are going to see it as a last chance because they know it's going to be dead in 10 years' time, so they're going to see it now.
I have a question about the peer review process.
Yep.
As you say, it doesn't work properly.
Yep.
Why doesn't it work properly? Is that in the selection of the peers who do the actual review?
Yep. Well,
Who
it's
has the power to select?
the fundamental problem is peer review doesn't take long enough, right? The peer reviewer isn't paid, right? So if I've done hundreds of peer reviews, right? And what happens is you get given the journal writes to you and says, look, we've got this paper, would you mind reviewing it? You say, oh no, I'd really rather not, but I better because it's your duty. And they send you the paper and you put it off and you put it off and you put it off. And eventually the journal editor says to you, you said you were going to do it by this date. You say, yeah, all right, I'll do it. And then you read the paper. Everybody's in this position, right? And you read the paper and it sort of looks okay and you write a report and, you know, and that's it. You're not going to get paid. Nobody will know if you've peer reviewed it and it's wrong and, you know, it's a total disaster. So there's no comeback on you. There's no payment for you. There's no responsibility for you. That's just not a way. That's not review. You need to be able to give a paper, if only the really important ones, you need to give it to somebody and say, we want you to spend months on this if necessary. We're going to pay you. We're going to pay you properly. And by the way, if you don't find an error that some other, because you can send it to two peer review, you don't find an error that some other guy finds, we're going to be pretty cross with you and you're not going to get paid for the next one. So those are the sorts of things that you've got to have to really serious peer review, the serious testing that you may find in an engineering company where when they make a mistake, somebody dies. Right? Nobody dies here. In 30 years' time, we may have sent a few farmers broke, but nobody cares about that. This chap here was... Sorry. Yeah.
Thank you. Well, we know that you have very powerful support in your country, Australia, Jennifer Marawasi.
Yep.
And she is supporting you very much and also keeping your enemies out of your home.
Yep.
But do you have any supporters in your own university?
Yes.
Who support you against the people who are running this university?
Yes, but the problem is that, and you know, the problem in universities, it may be a little worse in Australia than in Holland and other places, but I don't think it's much worse. That some of them have tried to come out in support, but have been squashed by the Vice Chancellor, right? So they've seen what's happened to me, and they know that they don't want to take that risk, and you can understand it. Now, in a sense, in my case, I was getting towards the end of my career anyway, so I knew I was taking a risk. I said to the group of people I've been working for the last 5 years, I said, I will leave this university by being fired. I don't know when it's going to happen, but it's going to happen, right? And so this is the sort of you know that if you start crossing the line too much, it's only a question of time. And of course, all my colleagues know that. But personally, a lot of them have expressed support for me. And some of those outside who are able to do it in a more public way have also done it, which is great.
Okay, thank you.
Yep.
Yeah?
Yep, sorry.
Okay.
Yeah.
Well, in my experience and my opinion, the way a research question is asked is already giving the answer. Do you recognize that?
Oh, yes, sometimes that does occur, where they're sort of almost chasing the data they need to prove something. I think that certainly does, especially with some of these marine biologists, yeah.
Also, let's say, a tunnel vision is incorporated in the research question, and they're all only trying to prove
yes
this, and no open view.
No, and that's
and excluding a lot of other possible explanations, causes whatsoever.
Totally agree. It happens all the time. We have a thing called the Great Barrier Reef Consensus Statement, which is like the IPCC reports, and it's just anything that they don't like just doesn't appear. So myself and a fellow called Piers Larkham, I'm going to claim to be, well, he doesn't, but I certainly do, claim to be the experts on sediment in the Great Barrier Reef. We've done more work than virtually anybody else. But our work just doesn't appear in the consensus statement. They eliminate it. And you see, the reason is that they only talk amongst themselves. The peer group has excluded everybody else, so that tunnel vision gets exaggerated and reinforced. And so what we have is exactly what you'd expect we're going to have. Peer review is a disastrous system.
And that's well, the killing of science.
It is, yes.
It's not science anymore.
No. No, there's no doubt about that. Yeah.
Suppose you win the case, then do you want your job back?
Well, while the Vice Chancellor is there, I don't want to go back. But I'm betting that I will be back at some stage in the future. I'm not quite sure how that's going to happen. I've got an inkling of idea how it's going to happen, but I will be back sometime.
That sounds ominous.
No, it's that there's.
Would you like to?
The Vice Chancellor's not going to be there forever, and I'm going to be in North Queensland for a while yet, and things are going to change, and I think I will be back at James Cook University sometime. Yeah.
Another question about peer review. Maybe one of the problems is that the result of peer review is published or not.
Yep.
Maybe it could be better to publish and have everything published.
Yes.
That's submitted, including the review reports.
Yes.
And I come to this because the Larry Sanger, who founded Wikipedia once, he just a few weeks ago announced a new initiative, an alternative for Wikipedia, where all views can be published.
Yeah.
And now there are often wars on Wikipedia and there's censorship, and Larry Sanger is sick and tired of that. So he comes with this alternative, and it could be a good idea for.
Yeah, there are so many things that you can do, but even there, if the reviewers aren't being paid, if they're still going to be cursory, you know, if you want quality assurance, you've got to pay for it. If you look at a big car company, you look at Mercedes-Benz, all right? I don't know what percentage of their costs actually going into making sure that car is good, but it's a lot, right? It's not 1%. It's a lot. If you spent just 1% of the amount of money you spend on the reef just checking it, you'd fix up a lot of the problems, right? You've got to pay for it if you're going to get quality. It's as simple as that. We have a system where we've got exactly what we paid for it. We paid nothing.
Yeah, but in such a system as Larry Sanger proposes, you can also add information on how much is paid for what. For the research, for the review.
Yes.
Everything can be done.
That's right. Yes, exactly. That's right. So there's lots of things that, and the good thing is that, you know, people are taking aboard the replication crisis. People are, you know, this is mainstream. This group here is a fringe group. We're on the outside. We're deniers, all right? But the replication crisis is mainstream. The big journals are talking about it. The Royal Society is talking about it. The American Academy of Science is talking about it. And this is actually an important way where climate people and Great Barrier Reef people like us can actually chip away at this edifice, because the replication crisis is just a fact. Yep.
You probably don't like that the university is going into appeal, but it might also be a way to get greater publicity for this thing. So how do you balance that personally?
Yeah, I mean, he said it's probably good because there's more publicity about the reefs if they appeal. Yeah, if we win, that's true. But I'd rather we didn't have to go into the appeal for all sorts of reasons. Yeah,
Personally, it's
yeah,
horrible.
that's right. Yeah. But you're probably right. If we do come out and we win, if we do come out and we win, it will show yet again that the university system has got huge problems, and it will also shed indirectly light on these problems. So what we've got here is two enormous problems. One is that our science institutions are complete rubbish, and the second thing is that our universities are complete rubbish.
And the legal system as well.
Well, I trust the legal system more.
No, because it's the party with the most money and hard best lawyers and so on. They can take years of your life. For instance. That's not fair.
I know, but bad as it is, I trust that, and I don't trust it a great deal. I trust it more than the science institutions.
But if you win, if you were to win, it might give a lot of strength to your colleagues who are now a bit afraid of speaking up.
I think the only thing that will give them strength is if there is a change of staff in the university. It's too risky. It's too risky. Yeah.
Could you perhaps inform the audience a bit about what you think about the papers for publications?
Sorry, the papers for publication?
The journals, sorry.
Oh, the journals. Well, the journals they're just all part of this peer-reviewed system, and they get captured just like the funding bodies get captured, so they're part of the problem. But they're not the main part of the problem. The thing about science is that I was just talking to somebody just before about, of all the scientific papers, about 95% are never used for anything. It doesn't matter whether they're right or wrong. There's a small percentage that's used by industry, and industry will check it, and we don't have to worry about them. And then there's a very small percentage, maybe 1%, maybe 2%, which is used by government. And those are the ones that the government then should check if they're going to use it for public policy. So that's not the journal's fault that it's wrong. Well, it's a bit the journal's fault. But if the government that it now knows that we have a replication crisis, which means 50% of what they have used is wrong, and they don't check it, then they are now equally culpable. Because if you know you've got a problem and you don't fix it, then you're actually equally culpable as the original people who made the error. Yep.
I'm a biology, so I have a little bit of a biology question.
Yeah.
Am I right to assume that the CO2 dissolved in the water is also the CO2 the coral uses to grow?
Yes,
so
exactly.
Is there any evidence that coral is limited by the amount of CO2 in the water?
Well, I think if it gets too low, yes, it would be a limitation.
For plants, it's the obvious years.
Well, I don't think there's much doubt for plants, and even water plants, an increasing CO2 will make them grow faster. So seagrasses will grow faster. But there is a question mark about these calcifying organisms. The thing is that they talk about the pH of the ocean, but the fact is that the pH of the fluid inside the animal is regulated by the animal, and it's going to do all sorts of things to regulate that pH. So I think the jury is out on that. If you want my bet, the result will be, if this was checked properly, is that the ocean acidification is not a problem. But I tend to be very conservative, whereas I know I am utterly sure that pesticides, nutrients and moderate climate change are not a problem. I'm as sure as I can be of that. I'm not so sure about the ocean acidification, so I leave it as a possibility.
I can imagine a shift to the real-life corals that you expect, because they're fast-growing. So I could imagine a shift towards that.
Well, you'd imagine there could be some change. I don't know what it would be. That there's some corals will grow better under a different pH climate relative to others, and you'll get a different species composition. People will say that's bad because it's a change. Other people will say, well, it's a change. Doesn't matter. There's still lots of coral there. Things have been changing since eternity. Who cares?
Are there laboratory experiments with these CO2 levels and so on?
Yes, so there's a lot of laboratory experiments. Some are fairly dodgy, some are more solid. Some of the ones on the reef look fairly solid and that demonstrate a reduction in calcification. Others seem to be more contradictory. So it looks to me to be all over the place at the moment.
I'm Leiden, so if I I'm asking you questions, but I do take a keen interest in science. I thought the ocean also acted as a buffer.
Yes.
So, in other words, if you have a lot of CO2 from the atmosphere, it's going to be compensated by chemical reactions.
Yeah.
They are going to unduly affecting pH. Is
That's precisely right. That if it was just fresh water, the swings would be much greater. But yeah, you need a very large change in CO2 to have only a small change in the ocean pH. That is true.
Hans, first question here.
Okay.
How are you?
Yeah, good to see you.
Yeah.
Well, as you know, I'm a member of the Netherlands Academy of Science.
Right.
And I have already for years a discussion with them to change the system.
Yep.
And what I noticed is that in the beginning they say, well, we have IPCC, so, we trust them and we follow them.
Yep.
Now I see a change and they get a little bit uneasy.
Mm.
But the problem is, how do they get out of it? I see they struggle.
Yeah.
With the problem that they say, yes, we have to tell the people outside that we were wrong.
Exactly.
And that seems to be a big hurdle.
Yes, it's huge. We've got a person called the Australian Chief Scientist, who's the main man that the federal government goes to, and he's published quite an interesting report on the replication crisis. He says we have a problem, right? But you think of it from his point of view, he doesn't want to say that we have a problem and that we could be implementing all this wrong. That he just can't say that. I don't think he actually believes it either, but even if he did believe it, how can he say this? So they're going to have to very gently get over this replication crisis problem without showing how incredibly unreliable scientists have been. But in fact, the Dutch are actually ahead of the curve, because the Dutch Academy of Science, what's the acronym for it? K? Yeah, that's right. That's right. That's right. KAW, was it? KNAW, yeah. They have actually got a fund for replication studies. It's one of the few organisations, national science organisations, that's instituted money set aside for replication.
But it's more on the physics side.
It'll be on other things. They don't want to talk about these things just yet. But in the end, you see, we're using this for the Great Barrier Reef, which, although it carries a lot of political baggage, it's not quite as bad as climate science, right? And we're using the replication crisis to convince the politicians that, if you've got a problem in medical science, why haven't you got a problem in Great Barrier Reef science? And they will say, oh, we've got the consensus committee, and you'll say, but it missed all these things. It's just the same group doing the same things, and they get that. But the replication crisis is a dagger at the heart of the climate alarmists and the Great Barrier Reef alarmists.
Maybe what we have to do is indeed not trying to persuade them to say, well, we were wrong.
No.
Because that will probably never happen.
No.
But tell them there is a replication.
Yes,
you have to
that's
do
right.
something about it.
Yes.
Yeah.
Yeah, that's right. And one of the reasons why I think the Great Barrier Reef case is much more important than perhaps you think. I could be wrong on this, but see, the whole world knows the reef is dead, right? If we can show that the reef isn't dead, and I think it's a lot easier to show that the reef is not in trouble than to demonstrate unequivocally that the climate change thing is a total myth. If we can suddenly change everybody's mind that actually the reef is fine, then people will start, well, if the reef was actually fine and they've been telling us for so many years, what about all these other things that we've been told? And this could happen very quickly. So you've now got generations, so everybody up to the age of about 30, ever since they were this high, have been told about climate change. And what's going to happen is in a few years' time, hopefully, that the wheels are going to fall off, and then they're going to question everything. It's going to be horrible because scientists are going to be exposed for what they are.
You have to be ready. Let us train.
My name is Frederick. First, a little remark
Yep.
I don't agree with the second line because there's a contradiction. You are convinced that the Great Barrier Reef is alive and kicking.
Yes.
Still you read still on all 3,000 reefs. That's the word still should go. Read it without.
Well, okay, yeah, okay. I suppose what I'm saying is that there was good coral 200 years ago, and there's still good coral there.
Sorry, be consistent in your argument.
Fair enough. I've just been peer reviewed properly.
The second thing is that a long time we have been speaking about the scientists.
Yes.
But there are about dozens of sorts of scientists. I myself, I come from elementary particle physics, and we don't have this replication problem at all. I mean, and there are lots of other branches of physics and chemistry where this crisis doesn't exist. And so I would like to have a separation between, let's say, science that deals with living and political issues, and science that just talks about fundamental constants and the like.
That's right. Well, look, I'm a physicist too, all right? That's my background. I'm a physicist, and, you know, there's so much physics which is utterly, totally reliable. But then you sort of stray. I think the worst area is psychology. I'm not sure it's even science, but they reckon in psychology that when you do replication studies, the amount that passes the replication studies is not significantly different from zero. So it's so low, right? And then you have the environmental sciences, which are not much better because there's ideology. In biomedical, there's obviously problems because people essentially don't understand about statistics. So it's not an ideological problem, it's just an ignorance problem. And then you get to the hard sciences, the chemistry and the physics, where by and large, I'm not sure that there is no problem, but I'm sure you're right that it's a much, much, much smaller problem. Maybe not worthwhile worrying about. Yeah.
So, as one of these persons in academia under 30,
Yep, good.
Considering the universities and colleges are also places of teaching,
Yep.
Is there anything that students or even young professors can do to influence the university's stance on these matters? Because, as you said, the university management has their own ideas of how science is supposed to be conducted.
Well, I think it's actually the opposite to the young people. There is actually a obligation on the older staff to do something. So when you're my age, you've got good superannuation, the children have left home finally, and you can take a risk. But you can't take a risk, right? You've probably got a mortgage. I don't know whether you've got kids, right? You can't take the risk. You'll destroy your career. You might not get fired, but you'll destroy your career if you get outside the peer group. Whereas the older scientists, like myself, they actually have an obligation to stand up. And it was slightly tongue-in-cheek. It wasn't tongue-in-cheek, actually, but people think I was tongue-in-cheek. I actually think we need an organisation called Kamikaze Academics. And the idea of Kamikaze Academics is that you will have one award every year called the Kamikaze of the Year Award, Kamikaze Academic of the Year Award. And that academic has got to be somebody who got themselves fired for something that was good and noble to improve the tertiary education system. I'm serious, right? And we need a $50,000 prize, and you can only be a Kamikaze Academic if you register beforehand, right? This is what I'm going to do. There's no point in, accidentally, because I'm not a Kamikaze Academic because I got fired by accident, right? I might not have been careful enough, but I got fired. You've got to say, that's right, this is what I'm going to do, and if I get fired, I'm eligible for the award. And then you have the failed Kamikaze Academic of the Year Award, which is for somebody who did something really good and failed to get fired, right? But I'm actually serious. It's the academics who are near retirement age who can stand up to my Vice-Chancellor or your Vice-Chancellor, or whatever they call him, and saying, this is not good enough, I'm going to challenge you, and you may fire me, but I don't care.
So do you think it's a change that will come naturally when the younger generation gets more skeptical, or should we just wait for the older generation to take up the slack?
Well, I don't think. I think that although I think science institutions will be reformed, I don't think there's any hope for universities. I don't think there's anything that can be done to fix them. I think that we need new institutions, and in a sense, apart from the genuine science, the proper science that is done, the particle physics, the engineering, some of the medical stuff that is done, universities don't fulfil this role of advancing knowledge like they used to, the free thought. That's occurring on the blogs nowadays. It's not occurring at the universities, especially in the social sciences. So maybe you just say, give up on universities entirely, just make them into training institutions, turning out good engineers, good lawyers, good doctors, and don't worry about a lot of the other stuff. And don't worry about the research component that they presently take up. Maybe.
Who do you think should fund your peer review proposal? You want the reviewers to be... Okay, don't you think then, let's say your system is in place,
yes,
that you run the risk that skeptical people will say, yeah, but those guys were paid by the government, so I don't trust that outcome anymore either?
Well, the government is the one that's going to... In the case of the Great Barrier Reef, we're going to be spending $500 million Australian dollars in the next few years, supposedly saving the reef. And that's on top of a whole lot of other things. The government spending the money, the government should do the checking. It's government scientists that are saying the reef is damaged. It'll be a government scientist or a government paid scientist who will challenge that. By the way, it will go the other way round as well. So, for example, if the government suddenly decide to believe me and say, we're not going to implement these new rules on sediment because Peter Ridd's work shows there's no problem, well, Peter Ridd's work needs to go up before the super-duper peer review panel to make sure that his work is fine as well. So it's got to work both ways. But the amount of money is trivial. It's 1% of what we're spending on the reef. That's all it is.
Okay, but that's a particular case. From what I understood is that scientists always have problems with getting their funding done for their actual project that they're trying to research, and this would be on top of that then.
1%. It's in the noise. It's in the noise. It's just a tiny amount. That scientist doesn't have. Remember, you don't have to peer review every single piece of science. For the Great Barrier Reef, even though there's there's thousands of papers, and there's over 1,500 that are used in the consensus statement, the actual important ones, and I've actually dealt with some of those here, there's probably 20 papers, just 20 papers that you have to check. And that's just not me. I actually asked this question of the chairman of the Great Barrier Reef Marine Park Authority, who's not a friend of mine on these matters. And I asked him, how many keystone papers are there which really go down to the heart of the problem? And in my mind, I was thinking 20. He said a dozen, 12. So we're talking a very small number of papers, and everything else is built in this inverted pyramid on about 12 papers. If you knock those 12 out, the whole thing falls down.
No, I understand that, but what I'm trying to understand is that, okay, there's a scientist who has worked for years and years on publishing a paper. He has done field work and all that. In the end, it will be another scientist. If you want to properly check his work, you have to get into the field as well, I guess.
Yes, that's right. In some cases,
that's not an insignificant or something that can be done in a very short.
No, it can be. It can be.
It will require serious.
No. It can be done in. We've got a proposal, 2 years, right? We reckon that most of the base data that we've got is actually reliable now. There are some things that do need to be done again, but they don't take very long. that calcification rate one, which needs to be done again, is by far the most expensive. It would actually take half the funds just on that one, because it needs to be done again. It's very expensive. But if you started tomorrow, you could have the results out certainly within 2 years. No problems whatsoever. Yep.
Okay, final question over here. Stand up.
You haven't mentioned the media. And it seems to me this group of peers is totally reliant on the media propagating their point of view. It seems to be a team working together.
Yeah.
CNN,
I mean,
BBC.
Yeah.
BBC.
Yes. Look, the media certainly need to take their share of the blame, but they are not the fundamental problem. You know, if you have a paper that comes out and saying we've lost half the Great Barrier Reef, well, you can't exaggerate that. You know, half the Great Barrier Reef has just disappeared. They've just reported what the untrustworthy science institutions have said. Don't blame the media. Yeah, blame them a little bit. They will blow it up. But even there, these unreliable science institutions are absolutely brilliant at framing things in a way that is... I'll give you an example. So, in the 2016 bleaching event, the statistic came out, 93% of the reefs bleached, right? Now, firstly, most people think that if it bleached, it died, right? So they've already exaggerated by not mentioning the fact that actually most of it will recover. But when they said 93% of the reefs bleached, you didn't hear the S on the reefs, right? What they meant was that they fly over a reef and there's, you know, millions of corals on it. If they see just one coral that's gone white, then that is one of the 93% of the reefs that bleached, right? Bugger all coral died, but that's one of the three. And so this 93%, they know that, and then of course the media get hold of it and say 93% of the reef just got killed, right? And so you contact these science, and I then respond and say, well, look, that is just not right. You should blame that science organisation. The science organisation puts its hand up and said, oh, we never said that the 93% of the coral died. We said that 93% of the reefs experienced bleaching. What we said was strictly correct, and it was. But they framed it in such a way that it was inevitably going to be exaggerated. And you've got to suspect, more than suspect, that that was done deliberately. That you can rely upon the media to exaggerate something like that, and they do. And remember, our university, well, my university, my old university, had 5 people feeding the media. They know how to do it. They know how to manipulate the media. And the media is very, very busy. They don't have time. They just bung the thing straight in. So.
Well, that's a good way to take it over, I think, as a journalist. There are some journalists here in the room. But I think, looking over there and over there, I think we agree with you. It's also my position as a journalist that the media, although they are exaggerating sometimes, is not the key problem. I once gave a talk at KNMI. In the lion's den, you could say, you know, and afterwards, KNMI researcher came to me and said, oh, if I listened to your criticism, we didn't communicate very well. And I said, no, you didn't understand what I said. you exaggerated the science, you know, so you have a larger problem than just communication, yeah, and I think that's the same in your field. Okay, and another big applause for Peter.
It's the Josh cartoon, Helen. It's 2019. It's our gorgeous to recycle again and again. I hope you didn't have that yet. Thanks for an excellent talk. Thank you all. Please stay around, have a drink. Please finish the water bottles in the back of the room to replenish yourself. Have a talk. We won't be kicked out of the hotel. yet anytime soon. I'll see you next time, next event.